Alright, so in the interest of the next video, not necessarily having to wait for the microcontrollers, I thought it would be prudent to just sit here and program a bunch of them to run without crystals. And I'm going to do that using the Arduino IDE. I could use the programmer on the phone with Z-Flasher. Unfortunately, my phone is up there, being a camera at the moment. So I think we can see this screen. You know what? Well, neither one of them is going to be very easy to see. But maybe I could do that. So I'm using this thing added to the Arduino IDE called ATTiny84, and you can get that off the internet by Googling it. I suppose I can be nice and find out who made it. I want to say Spencer Condi or something like that. Let's see here. Google ATTiny84. Yep, Spence Conde, whatever. It's on GitHub. It's not difficult to install. I would encourage reading the directions. It's not rocket surgery. You want to, in my case, I downloaded a zip file and extracted it into the Arduino folder. Once it's added, when you're looking in the Arduino program here, normally where you go to Tools and you click Board and you'd pick which type of Arduino you'd have, you can see we've added well, you probably can't see it very well because my camera is related to closely related to a potato. However, if you could see it, at the end of the list of types of Arduinos, we now have this category, this section called ATTiny84, and you can pick the different processors here. ATTiny4 lets me program the ATTiny microcontrollers. There's another program called Mini-Core, which I want to say is by the same guy. Please don't quote me on that. I guess I should be the nice guy and look that one up too. Mini-Core Arduino. And that is... oh, that's by MCU Dude. Okay. So it's a good thing I checked that out. It's a different person. It's also on GitHub. Same process, actually. I downloaded a zip file, extracted it into the folder. Again, I always recommend reading the directions. So in any case, ATTiny4 is the one we need for this project. And I'm going to go under the ATTiny4 section. I'm going to select ATTiny24, 44, and 84. Apparently they're all programmed the same way. I do not want the OptiBoot one. I want just the raw chip. So in the beginning of my code, and I do this always as kind of a note to self kind of thing, I always list all of the options in the beginning. And I'm going to follow them. Obviously, you should know what the options do before you click them. They're all rather self-explanatory. So I've chosen that board. Also under the tool menu, there's an option for chip. So is it the 24, 44, or the 84? They're all one board, but there's different settings for each chip. And I am in fact using the 84. This is the important one. This is the one that I actually have to set now, because if I do not set this correctly, once I solder that chip into a board that doesn't have a crystal, I'm done. So it says clock, and I have the different options. Each one says internal or external after it. Please pay attention to which one you're clicking, because they don't always get grouped together. Sometimes they do. Sometimes you'll see all the internal ones grouped together, and sometimes they're not. In this case, they're not. I mean, we got internal, external, external, external. We got 6 externals total, and then we've got another internal. They do not go in any order, so you cannot predict where they're going to be. So, make sure, if you're doing this, the critical thing is that you select some kind of internal clock. Even if it's the wrong clock right now, you'll still be able to program it once it gets put in the board. But I can't do that if it is looking for an external clock, because the board doesn't provide an external clock, and the processor simply will not be running. So, absolutely, make sure that you've selected the internal clock, and I'm going to go ahead with the right one, which is 8 MHz for this program. There's no reason this program can't run at 1 MHz, although the I2C thing suffers a little and gets a little wonky, so we're going to run at 8 MHz internal. So, then the next setting is this brownout detector. BOD stands for brownout detector, and that will automatically stop the processor if the supply voltage goes below a certain setting. And I'm again going to pick the right options because I'm here anyway. You want that enabled if you are using the EEPROM, which my program does. I found that out the hard way because I mentioned in the other video, I think I mentioned it, that I was having some EEPROM corruption issues. The problem was that somehow I had skipped this setting, and when the chip got powered up or unplugged, as the capacitor discharged, the voltage would drop, and if it happened to be trying to access the EEPROM at the time that happened, it would corrupt the data in the EEPROM. So absolutely make sure that that is enabled. I set it to the highest setting, 4.3 volts. That's in my notes. And I leave it there anyway. I could conceivably run it at a lower setting, but, you know, the regulator is on the board. If it drops below 4.3 volts, there's something wrong. So we might as well stop the processor. And when it stops, it kills all the outputs too. So if there was some other part of the circuit that was shorting things or pulling things down, those would get disabled when the chip stopped. So, next option is save EEPROM, and since I use the EEPROM, I need that. I'm not sure why we have the ability to disable that. Supposedly it speeds things up a little, I guess, but we don't need it. So I'm leaving it enabled, leaving the EEPROM retained because we do need it. So pin mapping. In ATTINY84 on some of the chips, including this one, there's actually 2 sets of pinouts, and I'm not sure if I can legitimately do this or not, but I'm going to, and hopefully I don't get sued. This is also from the ATTINY84 site. Here's their pinout that they've provided, and you can see, so the light bluish, pastel faded grayish bluish kind of color is the Arduino pins, and you can see that there are 2 sets of numbers. The inner number is the so-called clockwise number, and the outer number is the counterclockwise number. I'm not sure exactly why there are 2 sets of pin numbers that can be used, but for whatever reason there is, and since my code counts the pins this way, I need to make sure that the chip is set to see the pins that way. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 11, 9, 10. That's how I count. 8, 11, 9, 10. That's how I always counted, right? I learned in kindergarten. I went to a special school. I'm just kidding, by the way. I went to a good school. Anyway, 0, 1, 2, 3, 4, 5, 6, 7, 8, 11, 9, 10 is the pinout that I use in my code, so it's important that when I choose up here, I'm also selecting pin mapping clockwise. So, LTO, link time optimization. Shrinks your code a little bit. Not sure how it works. It's magic. Apparently sometimes it doesn't work, which is why they're giving you the ability to disable it. But in this case, I have the ability to enable it, and it does work for this program, so I'm going to leave it enabled because it shrinks the code a little bit. Tiny NeoPixel port. Actually completely irrelevant for my project. So I'm leaving it pretty much at the default. Milliseconds, or millis and micros, the 2 functions that return the how long the chip has been running, basically. I use those in my code, so I'm definitely leaving them enabled. Support is irrelevant. We're not using a serial port. So, that's all the settings there. So this thing is now configured to set the fuse settings correctly. So, I'm going to take my USB ASP, plug it into my handy-dandy little USB port here. See, it lights up. I'm going to get that wire out of the way so I don't short something. Now, these chips obviously do not have a 6-pin plug on the bottom. I did make this little board. It's ugly. And originally, when I first started doing this, I was using the Arduino ISP thing, where you can program the Arduino to be an in-circuit programmer or in-system programmer. So I had used these 2 Molex plugs because I didn't have pin headers at the time, and they're lined up so they'd plug into the sockets on the Arduino. I'm not using them anymore, so I got these DuPont connectors in order to rearrange these into the proper 6-pin arrangement for the ISP connector. So now I will take the ISP connector, which is labeled, and I use ground and VCC as my reference because I use black and red wires. They're the only wires that I bothered with a color code on. So I'm going to connect this in the correct direction. Actually, you know what? I'm not going to do that. I'm going to put a chip in there first. So And this board is, I made this board so it can do the ATTINY84 and the 85 also, so you can do the 14-pin chip and the 8-pin one. I'm probably not going to provide any information or link to that board because it's an ugly hack. I mean, I've got one crystal connected to 2 sockets, which is probably not working correctly, but honestly, as long as there is a clock, you can program these things. And that's all I use this board for, is programming. So, I did put the sockets in the correct direction, so the notch in the socket is pin 1, and pin 1 on the chip. So, same thing I always do. I'm going to try this. I don't know if I've tried it with this or not. I might actually have to squeeze these pins together. But I'm going to try. God, I wish I had better lighting. So I got one side of the chip basically lined up against the edge of the socket. And then I'm just going to get the other side in, hopefully. And if I can't, then I can't. I mean, I will accept defeat if I have to do this the so-called correct way. But I didn't. I got it in there. It's in there. Homemade taste, it's in there. I'm going to keep on using that slogan, which I really shouldn't because it's in my head, so I keep saying it without even thinking about it. But it actually is a slogan from some commercial product. I want to say it was a type of spaghetti sauce. But it pops into my head every once in a while. Every time I say, yeah, it's in there. I mean, that's the whole point of a slogan, right? They want it to get in. They want it to be in your head so that it keeps coming into your mind, and you keep thinking of buying that product. Well, I do keep thinking of the slogan. Unfortunately, I don't remember what company it is, so it's not encouraging me to go buy their product. It is encouraging me to want spaghetti, however. So they were partially successful. All right, pin 1 is lined up with pin 1. Now I will go ahead and take. Again, using my black and red wires as my cue, or as my key. I wish they made these things keyed. They kind of did. There's that thing there, but you gotta have a shrouded socket, which I don't. But ground, VCC, connect those in the right order. Good thing this is on video, because, you know, one of these days I'm gonna get something wrong and there's gonna be smoke. And if I happen to video it, I'll still upload that. That chip is in there. So now I'm just gonna go also once again to the tools menu. And I'm going to click on Burn Bootloader. And we're not actually burning a bootloader. I am not using a bootloader. However, this is the Arduino IDE option that they've commandeered to make it set the fuses. So I'll click on that. And done burning bootloader. So I do get these 2 little warnings every time I... Oh, more than 2. Wow. I get several little warnings every time I write something. This USB ASP I bought straight from eBay. I'm running the firmware that came on it. Apparently that firmware is lacking a feature that this thing attempts to use, so I get AVRDude set SCK frequency to 187,500 Hertz. AVRDude warning, cannot set SCK period. Please check for USB ASP firmware update. So they want me to update the firmware on that thing. I'm not going to because it works. If I get to the point where somehow it actually doesn't work for what I'm doing, then we'll explore updating the firmware. But at this time, I see no need to do that. So that chip is now programmed. So what's going to happen is I'm going to unplug that. I'm going to grab, I don't have a chip puller, but those little, these little grippy things seem to work most of the time. Probably not the best method. And sometimes they don't work at all, so who knows what's going to happen here. And I just try to get that under one side and very gently lift that side. And then I can wedge the thing in there a little deeper. The chip comes out nice and smooth. And I'm going to put this one in the foam block, a different 90 degree side. That's my way of knowing that I've programmed that one. So I'm not going to bother videoing the whole process, but I'm going to do 5 more of those for those boards. And then the next thing you see will be me working on those boards again. That's all.